Those of you listening at home, hi. We are just about to go through homework 13C-1. Hi, I'm back. And we're reading off the answers to problems 5 through 10. So here we go. Actually, I can just put this here. So kind of sort of right in front of the camera. Everybody good to go? Everybody have your paper routes? Ready to check off? Thank you. Number 5. The vertex of your parabola should be 2, -3. So 2 to the right, 3 down, put a dot. The height multiplier is 2. So instead of, normally the pattern for parabola, like you start at the vertex, you go over 1 both ways and up 1. So you get a pair of points, bless you. So normally it's over left, right 1, up 1. Then over 2, up 4, over 3, up 9. That's a normal parabola for 1, 2, 3, and 4. For number 5, the height multiplier is 2, which means it's twice as tall. So the pattern you use is over 1, up 2. Start over 2, instead of 4, it's up 8. So you should have dots at 1, -1, and 3, -1. You should also have dots at 0, 6, and 4, 6. And then make sure there are arrows on the top of your parabola, because it goes up forever. Does that make sense? Okay. Number 6, the vertex should be -4, +1. They got the sign wrong inside. It should be -4. So you go 4 to the left and 1 up, and put your dot for vertex. The pattern for parabola, you notice it's times 2, but it's -2. Times 2 means it's twice as tall. What does the negative do? Can I refresh my memory? What does it do to the parabola? It goes down. Correct. So from the vertex, you should go over 1, down 2. Put 2 dots. Then start over 2, down 8, and put 2 dots. So there should be dots at -5, -1, and -3, -1. That's the first pair. You should also have extra dots at -6, -8, and -2, -8. Does that make sense? All right, number 7 and 8, I'm going to speed up the reading a little bit. I hope nobody got thrown by the fact that there were halves in there. You could kind of ignore those. They were counting by halves as you go down on the line. They didn't really have to. The vertex, -1, -1. So 1 to the left, 1 down, put a dot. Then the next pair should be over 1, down 1. Start over 2, down 4. Is that clear on those? And make sure you put arrows on both ends of the problem. Number 8, the vertex is 2, 4. Be careful, they're counting by 2s. So you go 1 jump to the right, and 2 jumps up will get you to 2, 4. Put a dot. The pattern here is 3 times taller than normal. So it's over 1, up 3. You might have to do a little halfway thingy. And then over 2, up, normally it's up 4, it's up 12. So the very first jump should get you to 3. You notice if you do a 3, it has to be halfway between 2 and 4. Sorry, it's just, I will not do that to you on the test. I'll make sure they're counting by 1s, because this is kind of aggravating. But if you go over 1, which is kind of halfway, you're going to go up 1.5 spaces, because that's 3. So you have a dot kind of in the middle of nowhere. Then the next jump, over 2, up 12. So you go over 1 full jump, and then you go up 6 full jumps, which is right to the top, up to 16. Okay? Questions on that? All right, next page. 9 and 10. You had to find the vertex, which is 2, 1. It's best done by getting it in vertex form, which is complete the square. Oh, I should probably tell you. The vertex form should be y equals -1, parentheses, x minus 2, parentheses, squared plus 1. That should be your vertex form. Once you start at 2, 1, 2 to the right and 1 up, the pattern should be over 1 both ways, down 1, put 2 dots. Then over 2, down 4. Clear? And then the next one, this was for problem number 9. For problem number 10, it should look like this. Y equals 2 parentheses, let me double check this, x, I put minus -4, you can put x plus 4. So it's x minus -4 squared plus -3. If you absolutely had to, you could do x plus 4 parentheses squared minus 3. I'll accept that. When you graph it, the vertex is -4, -3. So 4 to the left, 3 down. And then the pattern will be over 1, up 2, over 2, up 8. Graph your parabola and put arrows. And it repeats 1 through 10. Yeah. Repeat it. 7. Yeah. The vertex is at -1, -1. So 1 to the left, 1 down. And then the pattern is over 1, down 1. Over 2, down 4. Make sense? And make sure you count properly. If your parabola looks like one side is wider than the other, that probably means you counted differently on one side than on the other. Any other repeats? Alrighty, questions? As I choke on my water. How'd it go? Easy, hard, medium? How'd number 9 and number 10 go? Completing the square? Nobody traumatized? Okay, again, completing the square, check the notes. There are 5 steps to completing the square. Set it equal to 0, cancel the C and leave it blank, undistribute the A if you need to, compress it into a binomial square and balance the other side, and then get it back equal to 0. When you get it back equal to 0, you'll get it in this form. Make sense? Any questions you want to see works? Now's a good time to ask. Going once. Going twice. Right? All right? You sure? All right, so if I put a problem or two like this on the test, you won't get traumatized? Got it, Vaughn? All right, take out your notes, please. Good news, bad news. The notes are going to be very short. The bad news is you do have homework, but another piece of good news is that you mostly already know how to do this. First, I'm trusting that everybody is committing the quadratic formula to memory. X equals -b plus or minus square root of b squared minus 4ac all divided by 2a. Also, during non-lecture time, you're welcome to try the speed dev deal. I've lost the word there. Competition, the speed, whatever. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, horrible b, all divided by 2a. By the way, it's nice to know what this is used for. It's not just an extra credit point exercise. If ax squared plus bx plus c equals 0, this is a way to solve problems like this, solve quadratics that are in standard form. If quadratics are in standard form with a, b, and c, you can plug them into the formula and get the 2 values of x. This works even if it doesn't factor. It works even if you can't use algebra. Question? Do you have to write this down? If you already have it, you do not have to write this down twice. However, this I would like you to write down again, even if you have it. What is the discriminant? It's a formula. Go. It's under the radical. So what's the little formula by itself? Correct. It does not include the square root. It's under the square root. B squared minus 4ac is the discriminant. It has 4 uses. Well, 2 big uses. It tells the number of solutions and what type. And the other thing is, it tells whether the original problem factors or not. Depending on what you get as an answer for the discriminant, just the discriminant, it'll tell you how many solutions you can expect and what type they are. What type does it mean? That's real or non-real. Real or not, you could say, yeah.
How did they figure all this out? Like, what the discriminant is?
We know that this formula existed at least 2,000 years ago in Babylon. So how did they do it? I don't know. Well, actually, I can kind of sort of show you this week. Kind of, sort of. I'm not going to do it today because it would take up too much time from your work time, but I might be able to do it tomorrow. But where did they come up with, where did they come up with the discriminant? It's kind of secondary to the question of where did they come up with the quadratic formula? And I can show you tomorrow. Yeah.
How many problems do you have to do?
Good question. The answer?
Wait.
Yeah. Go.
4?
Voila.
16? 22?
22? 22.
Hold your horses, I'll explain.
Oh, there's another one. Double one.
Oh, I skipped that one. I did it wrong.
I don't know how to answer you. Figure it out. All right, fine. I wrote 5.
Voila.
Wait, are we gonna do some today?
For people who are eager for the specifics on here, I'll tell you this much. The homework. The homework is number, I think it was 13L-2. I am going to split this into 2 parts.
Yay.
It's going to be 1 through 21 odd for tomorrow,
How do you do it that way?
and then 2 through 22 even for Wednesday. Make sense?
Wait, what? Oh. 1 through 21 odd.
Yeah, so 1, 3, 5, 7, 9, 11, blah, 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 blah.
3. That's too much math.
Oh my goodness. Guess which class this is?
Can we do the quadratic formula?
We'll talk about that a little later. First, the first cluster of problems are use the quadratic formula to solve. The second cluster is use the discriminant to find out how many solutions and what type. Now, what does that mean? Can somebody tell me, look in your notes if you have to, if the discriminant is greater than 0, which means it's positive, what does that mean? How many solutions and what type? Yeah.
Isn't it like 2 solutions?
Yep. Real or non-real?
Real?
Real. Correct. 2 real solutions. When you take the square root of a positive number, you'll get 2 real solutions. What if you have the discriminant exactly equal to 0? Andy, what did it do there? How many solutions and what type?
1 real solution.
1 real solution. Like square rooting 0. You will get a real answer, it's just kind of boring. one real solution. However, what happens if you have the discriminant b squared minus 4ac less than 0, if it's negative? How many solutions and what kind? Is a little bit of a trick question. You got it? Go.
Isn't it like 2 non-real or something?
That's actually the clever version.
Or is
2
it just,
non-real
like,
solutions,
really nothing?
0 real solutions. I'll accept that. By the way, if you write down 2 non-real solutions on the test, that could be +1 extra credit. Because technically you're not supposed to know that yet. I gave you a little teaser the other day. That basically if you take a square root of a negative number, you're going to get that mystery letter called I showing up. You do not have to know that. But if you know that there are 2 non-real solutions, which means 0 real solutions, this is what I'm looking for on the test. If the discriminant is negative, you have no real solutions. That'll satisfy this. But if you happen to know it's 2 non-real solutions on the test, you might get +1 extra credit. Everybody clear on that?
Light?
How do you tell, if I use it as an extra credit point? So, how do you tell whether something factors or not using this feast? There's one last test. If the discriminant is equal to what? So you remember, just go.
1.
That would work, actually,
Positive number.
but it's not the only one. Positive, only some of them. They all have to be positive, yeah.
Positive, no.
Doesn't have to be even, but you're getting closer, yeah, Annie.
That's a perfect square.
Perfect
Oh, yeah, I knew
square. Correct. If b squared minus 4ac is equal to a perfect square, technically 0 is. That means what? What if you're lucky enough to get b squared minus 4ac as a perfect square, like 49? What does that mean? Yeah,
A factor?
the original problem factors. We don't know how. It might be GCF, it might be magic pair, it might be difference of squares, who knows? But it's guaranteed to factor somehow, which is very handy to know. Brennan, question?
Okay, no, next,
Okay. Is everybody good on these? Believe it or not, I think that's all I have for you. So you are welcome to spend the last half hour. Go ahead and plug away at this. If you want to work ahead to the 2 through 22, they're the same type of problems, so it's not, you don't have to have extra notes for it. I just want to space out a little bit so people don't get completely overwhelmed. That should do. People listening at home will click like and subscribe, and we'll talk to you later. This is my hand waving goodbye. Bye-bye.